welcome everybody. We are the Data Hub. Myself and Damien are going to be speaking today. We are technical leads on this Data Hub. And resources and opportunities, welcome to our workshop. So this is the QR code that we're seeing, goals and expectations. So what the CS-DCC, I'm going to call it the Data Hub, slides off the tongue better, is to develop and implement a portfolio level plan to coordinate data assets, standards, and analytics across ICTs. And the goal of this workshop today is to start the conversation about how we can do this, because it hasn't been done before within Genome Canada. So we're not following a template. So we can see this as an opportunity to co-create something that is useful for everyone and meets these outcomes. So we believe that in order to accomplish these portfolio goals, that we have two key expectations from our community. Number one, that we should have open communication. That might be the Mick. Okay, if we can, I don't know how to run the PA system. You're good? Okay. Hello, Mick, and welcome again to the Data Hub presentation. So to accomplish the portfolio goals, two key expectations are, number one, can you still hear me? Okay. I'm on. Hello, everyone. We can still hear. Okay, excellent. Yes. Okay. We're good. Okay, thank you very much. And the French check, is it working? French, excellent. Okay, thank you very much. So two key expectations for us in order to co-develop, and that would be that we have communication between and among the ICTs and the hubs, and collaboration to build something together between the ICTs and the hubs. So in today's workshop, we're going to talk about collaboration, participation, and contribution for the development of a Data Hub output. I don't like what I'm going to talk about lists, but here we are. Because it's important, we have 2.5 hours, and I hope we won't take the entire time. We shouldn't. But we have, first of all, just laying the context of the Data Hub, data in its context, the resources that the Data Hub is going to be developing. We're going to have a break for discussion, and then we will go into some more of the specifics of some technologies that we have started up already or brought into the fold. The semantic engine, talking about the schema library or the data catalog library, the data harmonizer, and how we hope to collaborate together in developing data standards. And then finally, at the end, our start onto the more complicated voyage of data governance. So, data in its context. We all know data does not speak for itself, because it's more meaningful when you can actually place your data in context. This is things like your analysis methods, the associated publications, the formats, the cataloging information, the schemas which are describing your data, etc. And by adding context, we're increasing the value of data. We're going to be adding context that makes data more reusable. And when we add context and data is more reusable, it means that it has more value because it has the opportunity of being reused. You don't have to go out and spend the same money again to collect a very similar data set to something that already exists. So that is really why we want to be able to add context to data so that it can be reused and reinterpreted. Now, who here is familiar with the FAIR data principles? Pretty much everyone. Good. So if you're not, a brief introduction, and that is the FAIR data principles is that data should be findable, accessible, interoperable, and reusable. And a key critical point is it's for people and machines. And it applies to digital resources like data and software. And the formulation of the 15 principles was in 2016, endorsed by the G20, a leading design principle for the EU Open Data Cloud, etc. And what we always like to stress here is that FAIR is not equivalent to open. It's accessible, but it doesn't mean it has to be open. And that open is not equivalent to free. Now, in the FAIR principles, they talk about metadata as well as data. And metadata can be tricky because someone else's metadata can be someone else's data. An example that I like to use is that you have your cataloging information at the library, which tells you the metadata about that book. But if you're at a library, you might want to survey your whole collection to see if there are any gaps. So that metadata about books has become your data set for looking, evaluating the library collection. So that's why the FAIR principles are all written to apply to bracket metadata. So again, what is metadata? First of all, you can't identify metadata by looking at it. It's not special data. It's just data in context. It's data in a relationship. And the line is very blurred between what is metadata and what is data. Because as I said, one person's metadata is another person's data. So metadata examples like the title and description or tags and categories, the cataloging metadata, the analytical metadata, the data license that goes with your data, etc. So those are all examples of metadata. This is an example that I pulled out of Dataverse of a data set. So we have, in this instance, I'm concerned about the B information. The blue box is my data set, and then I have other additional bits of metadata, which is what is providing me the context. And the more context that I have, the better I'm able to understand it. The other example I like to give is my personal failing on financial systems. So I didn't have to log in very often, but when I did, I could never find the transactions that I had entered, even though I was putting in the date, searching the date. I knew the date. I'd have to go through and manually do it. And because nobody told me that that date was a financial year and 01/01 was April 1st. So that is a bit of contextual metadata that because I was not participant directly in that field, I was not able to interpret the data sets correctly. And I'm sure we have all come across this kind of example when we're working with other people's data. If you have not seen the video with SAM1, SAM2, come to me and we can share the YouTube URL because it perfectly encapsulates the problem. So on to the FAIR data principles. I'm not going to go through them. They're available on the web. But if you're like, oh, what does it actually look like for FAIR data principles? What are the things that I can do to add context to my data? It's things like adding persistent identifiers, the PIDs that people talk about, data vocabularies that we're going to be talking about as well, that lets you help harmonize the meaning. Your cat is my cat, or your bar is my bar, your bar is drinking bar, and my bar is lawyer bar. So, you know, there can be also different interpretations of words and about how to access the data itself, how to register the data in repositories, et cetera, et cetera. Just as an aside for the funders in the room, the EU, when they set about the cost of maintaining data, they put the price at 5% of all grants. So it costs money to maintain data. And if you're, I've heard poor stories of, I put in stuff for data maintenance and stuff like that, and they scratched it out of my budget. So you can't say, take care of your data for free, as it doesn't work like that. Okay, so 5% was what the EU had costed for FAIR data. Benefits of creating more fair contextual documentation, making your data more fair. First of all, you're going to be helping your present self, your future self, and your collaborators. You're going to be avoiding mystery data because you're going to have better descriptions. You're going to be able to tune the detail to the work. So what that means is that your calibration sets do not lead a lot of metadata because they're one-offs, ones and dones, right? You might want to be able to quick check or something like that versus, you know, this wonderful, beautiful data set that you've pulled together and cleaned up and you're publishing and you want other people to have access to that. That is something that should have more contextual information added. So it's not do all the work for every little thing. And what you're trying to do also is deposit better quality data with less work. Another brief story from my history is I did a PhD on the virus. And at the end of my PhD, I was like, nobody cares about this anymore. It's meaningless. It's not in the news. It doesn't do anything. And then 10 years later, COVID hit. And I had been working on SARS inhibitors. And my old lab called me up and said, hey, we're going through the freezer and we're pulling out your samples. So what data and what context did I have that was accessible 10 years later when suddenly it became something that people were interested in? Now, that would come to the point of helping others find and use your data. If you document well, you'll spend less time supporting the people who are using your data. You can remind them to read the fine schema instead of read the fine manual, and you're able to communicate your data context better. Maybe they're too shy to reach out to you, but they can interpret the data because you've added context, etc. And it's especially valuable in cross-disciplinary research, which is a major goal of this Genome Canada. It's trying to connect across research domains in order to help develop policy that ticks more boxes. That's my interpretation of the Genome Canada project here today. Very important about machine readability, helping machines find and use your data. Documentation should be machine readable, machine actionable. Think about the card catalogs. I remember the paper card catalog, and I could only walk author, right? Because it wasn't digitized. If you went to a fancy library, they had a second card catalog where you could walk subject as well, right? But with digitization, suddenly you can be like, articles beginning with the letter A from the year such and such to such and such. Like, you are much more able to richly search and use the resources when they are digitally represented. And what we want to also encourage is that the data is not the end of the story. The documentation, the context with the data. And if your contextual documentation is really good and strong and independent, it doesn't have to be published with the data. It can be published as a separate resource that can be referenced, cited, given a DOI, et cetera, so that others can also take advantage of the resources that you are building. Better science and better policy from better data. Now, what we like to say, this is a philosophy of the data hub itself. It's not about we're going to build, I mean, if we survey the landscape, which we have done, we've spoken with everyone, everyone is working in their domains, everyone has their favorite tools, everyone is not going to go into lockstep and say, do this because we said this is the better choice. You have made the best choices for where you are. And the challenge with current systems more is that the context is locked into the infrastructure. So you might be able to download the data, but does the cataloging metadata come out very easily? Do the licenses come out very easily? Are they in a machine readable, more standardized format so that other systems can interpret them the same way? So this is kind of a principle that we're following, that the context should be not locked into infrastructure, that when you pull out the data, we would like to see more of the contextual documentation to be portable and transportable together with your data, because it's that context that's helping you interpret the data and not let its information and knowledge be lost as it moves throughout the ecosystem. So we'd like to work on portable contextual documentation that's machine actionable, meaning there are standards applied to it, and also that it can be citable so that you can reference it as its own entity in its own right. Damien? Okay, so now we technical change.
Sure.
Right. Okay. So, oh, I see we're speaking at an angle, aren't we?
Yeah, but you should be able to see it here.
Oh, there too. Okay, good. Yeah, so I work at the technical level as well as Carly and others in this room, and so I just wanted to drop down a little bit low. What does this mean a little more tangibly? So we'll be talking about data schemas, trying to coax them out of all the ICT projects, and look at specific pieces of them. So to start, the data schema table field down to the individual attribute level, each field have 3 different kinds of name to them. And we're often used to working with 1 or 2 names, but we're trying to get up to a 3 component part. So the plain name is a default plain language, user-friendly English name in a project used in project or database applications, spreadsheet column names. So there you're seeing a variation between projects around the world. Birth date, in one word, date of birth, born. We're expecting that to be variable, but we want to anchor what's being measured with another name. So we're recommending a coding name to be accompanying each of these UI-oriented, human-oriented names. So a coding name is a standardized computer programming name, supports data processing, and there are actually standards out about that within the Python and R world, for example. So looking at those two programming and analytic environments, well, it turns out they have the same standards pretty much for naming. So we're going to be advocating that our projects use these coding names so that programmers don't have to, and statisticians don't have to futz with the names to get them to fit into their applications. No needing to hire people to transform that level. And then lastly, the structured vocabulary identifier. This points to a commonly used, publicly accessible, and precise vocabulary term. That's the icing on the cake in terms of comparability. That's the one thing that machines can't know when two data items fields are actually comparable just by their label or even by their coding name. But we need semantic reference or a controlled vocabulary reference to know if any two data sets are comparable on some field. So how do we get a data schema that can do all three of those things? Let you name whatever you want, provide a little bit more of a standardized coding name, and then provide that semantic identifier to allow automated comparability in data. So in a way, I'd like to say this general message here is that data science is trying to create an Esperanto language of the different domains using these standards. Of course, ontologists think we have a really good role here in that last semantic web reference to pinpoint vocabulary terms. And so there is a whole other infrastructure of ontologies as one kind of controlled vocabulary that we'd like to talk to you about in the coming years and explore how much that those communities, those open source communities that are curating these domain-specific and application, more general application ontologies, how much they can support your effort, what the gap analysis is between what you folks are collecting and where these vocabularies need to support you and help liaise in that relationship to help get the terms, necessary terms in. I'm familiar with the OboFoundry family of ontologies. That's mostly life science, biology, and biomedicine inspired set of ontologies that started with the gene ontology as the flagship success stories to cope with the million cancer research papers being pumped out every year and so on. So there are a whole other family of ontologies that cropped up using the same kind of set of curation standards, and we intend to draw heavily on them in this project. So you can see the food ontology there. I helped curate that. CBI classification, offering taxonomy, anything that's been sequenced. Chemical entities of biological interest. We're going to be finding nitrogen, carbon dioxide, all the elements in the soil. There are other ontologies specializing in nutrients that reference study, for example. Okay, so I guess following this, so say we're coding all these ontology terms in. The fair data principles are really relying as well on the catcher at the plate, relying on search index engines to index these data sets, and according to how you describe them, but also in the future, more machine recognition of what data is out there. So they're increasingly taking advantage of ontologies and other controlled vocabularies. So here's fairsharing.org. It doesn't have a lot of data sets, doesn't have the universe of data sets in it, but it is using a controlled vocabulary language, including a lot of idiom ontology terms to classify the subject areas of your data set. So we'll be concocting advice about where and when, where you find topical controlled vocabularies for your project to relay into these engines. Back to Data Hub resources.
So don't be too concerned just yet, because we will talk about ways that the Data Hub can support talking about some of these ideals that we're talking about here today. Actually, good segue, Carly, into the next section, which is about the Data Hub resources that we have currently established. And this is just the beginning. And we want, of course, to have a dialogue with everyone to figure out where we're going next. So currently what we have set up is we do have a web page, and the web page, French and English, and it was on the, I'll be showing it throughout the slide deck later on. And it was also on the, it's been in emails, and it was on the handout that came handed out yesterday to everyone. And I don't want to bookmark a million things. You don't want to bookmark a million things. That web page, the idea is that from there, we will link out to all other resources. So that when you find the web page, then you can find other resources that both Data Hub and KMIC, who's not KMIC, will be producing. So one of the first things that we have established is the knowledge site or documentation site in both French and English. We wrote it in English, we Google translated it into French, and our French collaborators have gone through to correct the really egregious errors. So thank you very much. It's a lot of work and appreciated. And we also have a harmonization hub. So when we talk about any kind of data standardization work, that work would belong in the harmonization hub. We want to have we do have a schema library. And this is the idea of a kind of a data catalog without the data, so that ICTs, we've heard this from other kinds of projects that we have also been involved in, that people would like visibility of the kinds of data that other projects are collecting. So this is a quick way that we have established in order to be able to share what kind of data schemas other people are collecting without it being embedded into the persistent permanent infrastructure of like Dataverse and other these larger repositories. Because maybe it's your work in progress data that you're collecting, and you're going to be developing those schemas further. Then if the ICTs are interested in GitHub repository hosting, because perhaps they want to have a space where they can collaborate with other groups, we have that available as well. And we are also establishing a discussion forum, metadata discussion, protocol development, protocol sharing, analytical methods, analytical advice, analytical standardization, governance and license development, etc. So the first thing is our Data Hub webpage with the logo that we invented. And as they mentioned in the previous meeting yesterday, that one of the outreaches from Ag Act is to improve our communication with a better web page. But this one works right now. It's up, it's live, URLs are up there, and it does have the links. If you scroll down, which you can't right now, it does have the links to other resources that we have been developing. The web page will be updated, it will be live, it will link to all of our other resources. So please bookmark the web pages. Now, we are technically in phase one, the prototyping phase. So some people weren't aware the Data Hub, like the ICTs, went through a proposal, competition, a selection, and we are going through a series of gates for the development of the project. So right now in the prototyping phase, we are working in an environment that needs to be quick to launch, good for collaboration, reasonably familiar within the team members with consolidated features, and having readers and creators, consumers and producers documentation and standards. So in our prototyping phase, we have, after also meeting with different ICT groups, recognized that there's a certain baseline familiarity with GitHub. And GitHub checks a lot of these boxes because it is publicly available. It's low cost or free. It's excellent for collaborative projects. And what I also appreciate about GitHub is that any skills that you develop in GitHub is something that you can take with you to any other project, because it's not a proprietary system that you've had to learn, et cetera, et cetera. So I hated GitHub. I did hate it, and now I love it, and I really love it, and I'm not even that particularly advanced of a user. So you might also fall in love with it too. Open up your heart and give it a chance. Because we have a documentation site in French and English as well. So this is something that's written on GitHub and hosted on GitHub, and it appears like a website. Also, our website is on GitHub as well. I mean, you can do a lot with it. So right now we have a documentation site in French and English. It's a knowledge resource providing general information. We didn't want to rewrite the web. So we have a bunch of introductory topics, and then we are linking out to further resources, further sources of information. If you have any good resources that you like, we can add this to this as well. And the idea is that you have new students starting in the lab, somebody's never heard of the FAIR data principles, you can start them here. You're like, oh, we're going to be talking about ontologies. I don't really know much about that. There's a nice little introduction about the process of data standardization, et cetera, right here. It's a place to start new members, to learn the basics or review the basics, has advice like don't delete your raw data, which don't overwrite your raw data, which you would think should be, but sometimes people need to be reminded or instructed about that. And we are going to be updating the content and translating what we produce and linking to resources that we find that we think are suitable for everyone. And the reason that I want to highlight the documentation site, because if you are not a fan of GitHub, I was not a fan of GitHub because every time I go to a helper page, it was written by a bunch of coders who are talking to coders who are immediately in like sentence 3 or like, and then you spin up the command line interface. So you don't need to know that in order to be productive and produce good things in GitHub. And we wrote a basic concepts training, 3 pages long. You can get going with page 1 in our documentation site. So if you're starting with GitHub, if you have trainees that are starting with GitHub, please check out this site and in French and in English. I apologize, the pictures are in French because if I put it to French GitHub, I will never get out. So, but it goes through like the basic, what do we need? We need basic navigation. We need to edit text files in Markdown. We need to have files and folders. And then after that, because we're talking about establishing a collaboration hub in order to work together on standards. GitHub is widely used for standards development because it's great. It lets you track history. It lets you have discussions around topics, et cetera, et cetera. So it does fantastic work in collaborative editing with, excuse me, pull requests and branches. And then in the final section, if you do want to work on things on your computer, it talks about how to push and pull so that you can work with GitHub and GitHub Desktop. So before you despair, please have a look at the GitHub training documentation that we have added in our documentation site. Any additions? Is there any specific or introductory material that you wish your students could just come and read and so that they could start? Do you have any favorite education resources that we can link to? Please reach out to us, give us your favorite links, and let us know where there are gaps, and we will add that to the documentation site. So we're trying to help everyone get onto the same page. You don't have to read it start to finish, go to the parts that you want. It's not that big. and have a look around. Yes, absolutely.
From people. Do you have any sense of how the data use collection policies of Microsoft match the data governance issues of projects?
Good question. We have set a lot of these stuff up as public repositories. So it's going to be open on the web no matter what. If we have concerns about that, I think we should absolutely look at another alternative that we haven't set up yet, but we could run like our own local version, a controlled version of GitHub that is money and resources. So that might maybe outside of the prototyping phase, that's something that we could set up. If you have concerns about that or a bit more knowledge about that, please let's have a conversation. We are also looking for a discussion forum. Right now it's set up by default within GitHub, but we're looking to run our own Discuss platform. So that would be outside of the hands and fingers of Microsoft. Yes, Will. Oh, sorry. And remind me, I have to repeat, I forgot, I have to repeat the question for the recording and the translation. So the comment there was that we can kind of separate our ability to work into more public forums, which would fit well on GitHub, that are more technical and general and specific things related to sensitive data. We would have a more personal, private discussion hub, or that those kinds of details then would not be part of the data hub, but part of your own personal analysis. So we are not going to be storing data on GitHub. We're going to be working together onto ontological terms and ideas that go into data license agreements and ways to analyze, like how would I anonymize or pseudonymize my data, not the act of doing that itself. Good question. So on to the idea of the harmonization hub. So this is GitHub, and we have here created, we have a community organization, and in that organization we have multiple repositories. This is an example of a repository that we have, the Harmonization Hub, and this is where we think we will be doing the development for the data standards, and also where we will have the library of data schemas from all ICTs. So we have two parts here. We have data standards and we have the library. So in the library, which I will be talking about after the break, the idea is to try and meet the needs of a searchable catalog of each ICT to share not their data, but their data descriptions. And that, so what all of the schemas are markdown files. So we have a tool for documenting tabular data and exporting it into a markdown, which makes it searchable via this website. But if you have already, don't redo work if the schemas already exist, because in genomics, there's a lot of really nicely completed schemas for genomic and metagenomic data. We're not recreating that work. We can add that into the schema library. But there's a lot of dark data, like dark matter, dark energy, dark data. The dark data are the ones that don't have a lot of people collecting the same kind of data. They're, you know, I went out and did rumination color and lameness measurements or something like that. So not something that's repeated over and over again. So especially that kind of data, we have developed tools that help people surface that data and make it accessible to machines. So whichever way that we're using in order to get schemas, we will get a markdown version of the schema. We can put it into the library. It becomes searchable and divided in. We have it set up so that each ICT has its own folder, so you can see what other ICT groups are collecting. And then we have contact information so that you could email the owner of that schema. If you'd like the schema put up there, that's certainly something that we can establish. It just depends on people's comfort levels with doing that in GitHub. It's easy, but it's another step. So let's start with this step here of just making the markdown files. We also talk about the need for a discussions forum. We would really like to have a lively discussion forum where all the ICT members are able to participate, to talk about standard development, to talk about analytical questions, etc. The goal of this is to improve transparency and communication. We want to minimize the number of emails that are being sent back and forth between ICTs and hubs. And so we're looking for a discussion forum that has topic-based discussion, that's threading. We want to be using GitHub for single sign-on. So when you have a GitHub account, you will also be able to use that same login account in order to access any discussion forums that we set up. Excuse me. Self-hosting in Canada, supporting private conversations and secure discussions, allowing that you can sign up for email summaries of discussions that you want to follow. So we are looking at several options, including right now we have set it up with GitHub discussions, but we can very quickly set up another version. For example, we're looking into Discourse, but there are other opportunities right now. Does anyone have any comments or feedback about any kind of discussion forum right now? Yes. Yep. So the question is, what about using Teams for discussing across all the projects? I like Teams for discussion and Word documents and stuff, but it also doesn't have so much of the capabilities that we do have within GitHub for publishing and pull requests and tracking. I mean, we can have this discussion, but it does, or we could do like a Teams login and like a GitHub login. But I also know that it's not the most comfortable when you're if you're all within the same organization, it works great, but it's not very comfortable at all when you're coming from the outside. So that might be quite a barrier. Yes. The statement is that with collaborations within government, even if they have teams, they can't join your team. Probably there's restrictions on security and privacy. They do have a special version. Yeah. So the education system and the government system of teams are restricted and unable to collaborate. Okay, thank you. Yes.
Everyone is using, I feel like it's out right now. Every project, every big scale, large scale project is ontologies, and so we have now 5,000.
We have a proliferation. The comment is that we have a proliferation of ontologies that go with each big group that's working on things. Yes?
Are you looking at where are you collaborate?
Are we? Yep. So how are we looking? Are we looking to create ontologies or find ontologies? Damien, I'm sure has something to say, but why make when you can reuse?
Yeah, definitely. First step, gap analysis. Find out what the vocabularies are needed in ICT projects. Then go to gap analysis. I'm all about non-siloed use of non-siloed ontologies. We're talking about externalizing the vocabulary layer, not the knowledge layer, but the vocabulary layer of your organization, your project. So that leads us to a scenario where you can create an organizational ontology or project ontology, but the emphasis is on importing. And there's also the other short-term gap stop, which is you do get to mint your own terms because they just don't even exist out there. But you, from the beginning, code in a deprecation and replacement process for the day when those ontologies are there with the right terms for you to import. So every step we're encouraging this this language that's out there rather than your own siloed empire of language. No matter how big your organization is, you'll find your curational ability starts to drop off, naming diseases, naming soil types, naming bacteria characteristics, and so on. So this mission to create an organization-centric ontology needs to have the ability to externalize semantic components of that.
So reduce, remix, reuse would be the general summary of, yes, better to reuse than to recreate for sure. Now, we said that we have ICT repository hosting on GitHub. If you would like, if your IC team would like, we can set up private GitHub repositories for your team on GitHub. And that could be a place for you to have like your private code repo or development or something like that, that perhaps you wanted to provide access within the group. So how do we take part in this? What is the ICT participation workflow? So the documentation and the schema libraries are open to the public to read. We could look at changing that, but that is right now how they are set up. And because the documentation is very general, and we have a Creative Commons license attribution, non-commercial, I think. It's written there with that, and the schema libraries also are open to read. Probably, I haven't discussed, well, what kind of Creative Commons license would you like on the schema libraries? I think a non-commercial attribution, non-derivative at the time, and then that's something. So we will put that kind of license on the schema library, and in the future, of course, you can take that markdown, those schemas, that documentation, and move it outwards. It's your creation, it's your ownership. After that, all members, we are requesting that all members get a GitHub user account. And with that, you will be able to join any discussion, whichever the discussion forum that we set up, because we can work with open authentication from GitHub into another software. To add schemas to the schema library will be via GitHub, and also for the contribution to standards development, we see that happening in GitHub. Also, the future work that we want to do on data governance and data licensing, etc. GitHub is really nice because you can see all the changes that people have made, and you can do PRs, so you can have nice review, and things aren't quite so mysterious that way. So if you could please send your GitHub username and your ICT group, because then I will put those GitHub user accounts into specific ICT teams, and that way we can have team by team control in GitHub. There is the email right there, info@climatesmartagrifood.ca, rolls off the tongue. So that gets checked every day, French or English. Google Translate works for me, does it reasonably well. And then we will add all the users that we get into the GitHub organization, and that way you can have access to the different repositories. And each time, when you have your GitHub username with an ICT group, I will also give that group access to the private repository for those ICT members, whether you want to use it or not. So now we're early, which is good, I think. We wanted to break for discussion. This would be an excellent opportunity for you to sign up to GitHub and send me your GitHub user account, and email everyone in your lab to do the same. So there's time right now for you to do that, and we can walk around and help you with that if you need it. And so I'm going to leave this up here with the email addresses as well. And also, what topics would you like to see added to our documentation? If you want to scroll through that and have a look. What webinars would you like available to your team? Certainly at Guelph, not in the Guelph ICT group, but in other Guelph groups that we've talked to, they would really like an introduction to GitHub. And we can certainly run that webinar and we can record that webinar. And there are lots of great technical welcome to GitHub things that immediately start on the commit history and command line interface. And we will have a different way to approach that through a very functional, practical, here's how you upload a file and edit it in Markdown. So now we'll take a break now for 20 minutes from 10:20. So we will restart again at 11:10. And yes, I'm going to pause the yes. You're right, I can't add. At 10:40. Thank you. Yep.
What's the expectation of the longevity of their GitHub site after year 4? Because like if we're developing these schemas, there's a good chance we're going to want to use them other projects going forward. Yep. Would all of that information that we put on be transferred over to our personal GitHubs, or is the ICT lasting? Because we're gonna, like, a lot of the collaboration is probably going to come after we've met our own deliverables, and then we have an opportunity.
Yep. Oh my goodness, it picked it up.
That was loud for you.
Excellent, thank you. Okay, so the question is, where does everything go after this? Does it go out to the pasture to die, or how can we make it last longer? So we see there are two phases of work that we see. There's the active phase and there's the repository phase. So what we hope is that during the active phase, we will be developing standards, specifications, things that we can share. And we think it's very important that, that for longevity, we should insert them into existing resources. So for example, what we have been doing at the University of Guelph, if any standards any schemas that we are developing, is that we are putting them up with their machine and human readable parts into repositories such as Dataverse, which have a Core Trust Seal longevity to them, or are applying for that anyway, and they're given a DOI that's citable, version citable, DOI. Then you publish your paper and say my data is organized according to schema DOI such and such, and then you can you can save that. GitHub. GitHub has a fair amount of longevity, and they're all plain text files. So it is nice and easy to be able to move those resources out of there and into other resources. Like if you want to have active development and stuff like that, certainly any development work that we are doing that people want and like to take with them, we can assign that. Of course, the data could continue with funding, and we could continue to support this work and and develop it, because of course the data hub that we're doing is not just for climate change, agricultural data. We're being very explicit that data is data, and it's general data and general processes. We're also trying to make sure that what we develop is transferable from here. That's why GitHub, you can walk away with those skills. You can, you haven't learned some proprietary system that always needs a lot of money to keep going, and when it goes, you can't take it with you. So those have been design philosophies of the data hub, and that also any kind of schemas, they should be machine readable, they should be accessible, they can fit into other repositories. We should be contributing to other existing ontologies and sending them off into existing spaces, etc. Well, we designed the hub this way. We know there's a learning curve for GitHub, and so but this is a capacity building exercise where we can show you the skills, and then we can take those skills and go outwards, pull them into other projects, reuse things, etc. But using the same core resources. This is how you can build your future projects and take the things that you have already developed. It's going to sound really bad on the recording, but anyway. Okay, so we are still having a break until 10:40. That's in 15 minutes, and I'm going to turn off the AI translation. The microphone is now recording for the Teams. I'm going to now start again. Translation. Okay, the translation is now started again. And now I'm going to pull up the second half of our talk for today. Thank you very much. Yes, please keep those GitHub account users coming in. On to some of the more practical details of how we can enable this. Now, we're not talking about everything that the Data Hub is going to do. This is what we have at the beginning that we can do, and we will do more things in a similar vein. So the semantic engine and the schema library. So this is for documenting data. There we go. So the semantic engine is something that we have from the University of Guelph that we are to the Data Hub project. It's a suite of tools. We call it the semantic engine. It's about an engine for generating meaning. That's it's helping our researchers write rich contextual and machine readable data documentation. There's lots of great standards out there. Our niche has been with little expertise in writing JSON and understanding schema structures, etc., that you can document your data through a website and at the very end get out a nice JSON, that machine readable version of your documentation, so you can reuse it in multiple contexts. What is a schema? We have a data set and the attributes of the data set. So attributes, aka column headers, aka variable names. These are something that can be described in a schema. And we can give multiple types of descriptions that I'm calling these features, various features of your data set. And you can start with a few features and you can add more features to help better describe the data that you are using. We can add, like I said, add more details to improve a schema as needed. So coming back to Damien's talk about the attribute, you can see I have those as coded names. So these would be your column headers in a computer readable format. Don't put micromolar in brackets with a percentage sign or something like that. The computer chokes on it. You start good. Start off with an attribute such as what I've shown here, and then give it a human-friendly label. That would be your human readable label. And you can, of course, also give those labels in other languages if you are looking to collaborate in multiple languages. And then in this example, I'm giving farm information about those attributes. If you notice, I wrote them, and I don't know cows very well, so they're not very descriptive. I've got a great one that somebody gave me, and it's got chicken gut, and it's called glucose. And I'm like, did you grind up the chicken and measure the glucose? Did you like swab the stomach and get the? I have no idea. I'm not a chicken person. I love if they could describe for me, and it's not in publication because it's supplementary information. So I still have yet to know to this day what that is measuring. Now we have the tool is available for anyone to use. It's at the semanticengine.org. That's a screenshot of the web page, and the general flow is that you are either going to, in a perfect world, you are going to document the data that you're going to collect, and then you're going to go out and collect the data. And you know what you'll be collecting because you've already figured that out at the beginning. However many times it goes, I go out and collect a bunch of data, and then I document what I actually did. So both of those flows work within the semantic engine, that you are going to either know what data you're going to collect, or you have the data set in front of you and you are writing out the meanings of all the things you have collected. After that, you're going to download the schema, and then you can reuse, update, share that schema so that other people also can look and understand and reuse your data. The whole point of the semantic engine is that it's self-directed schema authoring. So we have tutorials and videos, and we have the site now in both French and English, and subtitles on the videos. And the idea is that you can send somebody to the semantic engine and say, look, thank you for the data set. It's great. Could you please describe it for me? And then you can come to this site and you can go through the steps and you can learn how to document your data. And you don't have to be like, oh, I can think about writing units down, and you don't have this back and forth happen. So that is what we have aimed to do with the semantic engine. Like I said, it's full of help pages and video tutorials. This is an example of how you would be prompted through a graphical user interface to start adding units to your data and describing what kind of data type it is. And then the critical point about this that we wanted to, when we were building the tool and the feedback that we were getting, is that after you've written your schema, how do you reuse your schema? How is it useful to you? Not just for, and then I put it in a repository and maybe somebody else will get it. So what we've done is that when that same story again, when something is machine readable, you can put it into other flows and you can reuse it and you can have it come out in different representations. So one of the representations here is that you can drag the machine readable schema that you or somebody in your lab has written, because an example that we also like to talk about is you are going to hire a bunch of students for the summer who are all going to go out and take measurements. So you have developed the schema for everyone to use, and you have you use that schema that you have to generate these data entry Excels. So they are Excel sheets that have been formulated for data entry, and then they have if you've specified lists, this is so that you don't get 5 different spellings of the same thing or short forms to help with the data wrangling before the analysis. And then it also has that nice schema description so that you can look up and say, oh, what unit am I supposed to be collecting in? Exactly what am I supposed to be measuring again? And with more detailed information, of course, you can do a better job than my guess is right here. Also, tools that we have available on the semantic engine that anyone can use is you can drag in your schema, and then you can drag in a data set. And through data verification, you can scan through your whole data set and find out where perhaps you called it National Research Council instead of calling it NSERC, which is what the data was expecting. So those kinds of harmonization can happen very easily because you've already written your machine readable data schema. And then finally, what we have added for this project is a schema library. So this is a public, this currently, but give us feedback. Currently, this the schema library is publicly accessible and publicly searchable because you've already written your schema, you've documented it using the semantic engine. You can create it in a machine readable format, you drag it in, and you can export it for your ICT group in a markdown file. And now you have your complete markdown file. You can just drag that into GitHub and it'll automatically be added to the schema library. This is an example of a bunch of schemas that we have done here at the University of Guelph for the research barns. So now those data schemas are up and available, and you can click through and search and find out what data is being collected at the barns. It's very easy to do this. I'm going to now take a moment to demonstrate the things that I have briefly described about how to get schemas and how to get them into a library. So first off, here is the Climate Smart Ag site. And this is where the schema libraries are, and the knowledge site, for example. So in data documentation, we have a section describing those figures that I'm reusing about how to write a schema, how to use a semantic engine, etc. So into the semantic engine, here we are. Again, video tutorial about how to do this. I'm not going to write a schema from scratch. I'm going to upload one that I already have. Right. The more I talk, the worse the tickle's getting. This is annoying. So I have a bunch of tools. There's more descriptions here on the left about how to use things. So I'm going to go in right away and I'm going to edit this schema. This is saying that, hey, a well-formed schema has to have a few things that are mandatory. So here, this is a schema. I have the translation in French and English. I have help information, help with this page, pulls up additional tips for everything about how to go through and use it. So on to the next. These are the different attributes, which are the code names, the machine readable versions. These should be the column headers in my data set, the kinds of data, and if I need to add something or change something. So here, like for example, if I'm adding another research farm, I can go in and add something like this, then etc. So this is lining in with Damien's point about the use of ontologies. That say you're collecting the disease, don't make up your own term list of diseases. Come to Damien and our group and get some help to find already existing term lists of diseases so that we can have it more standardized. Certainly, and your students are of course invited to as well when you are starting a project, or if you're going, because you could have your entry code be the made up term list that you came up with, and then your English terms and your French terms could be the term list, or you vice versa, which would be better. But the point is that we can make those connections. So here I have also the people who have sampled from this list. So I have a few that are selected lists, so you can't just put in your own spelling of something. And going through again, adding those more deeper description labels. I had ChatGPT write these labels, so they're not correct. But I didn't know what they were, and it wasn't communicated to me with the data set. Adding schema features. Again, this is where I said that you can continually enrich your data set with more and more feature descriptions. You don't have to do everything all at once. You could just start with the attribute names in a description, for example, and then go through and edit a schema that already exists and contribute more when you are looking for clarity, etc. Then at the very end, you're going to finish and download, and we give you the schema here in two different formats. This is your archival text, human readable format that kind of defines what a schema is, so that in 20 years, if somebody comes across it next to your data in a repository, that will help them understand what the data was collected. And then we have this machine readable format right now in zip. So coming back again to the semantic engine, I'm going to put in that schema again. And I'm going to add catalog information. So we are the data hub scenario. So I'm going to add, this is so that it shows up in the search on the schema library. You could have added this directly in Markdown, but we made a little form so that I'm going to add it to the loop scheme. So I'm going to generate the Markdown README, and there it is. That's the Markdown file. I'm going to open up the folder so I can drag and drop that in, because then I'm going to go on the screen disappeared. But here I am. This is the GitHub repository. So this is our organization. We are Climate Smart Ag Collab. I'm an administrator, so I'm going to see a lot more than you might. We have links to everything. We have the documentation. We have links to the website, because we're trying to link things so that you don't have to memorize things. And then we have our schema library. So in the repository, in the harmonization hub, I've got, this is where hopefully we will work together on standardizing data. And the reason that we wanted to build a library is that we wanted that other ICT groups are able to look and see what other groups are building, and that we can maybe look for overlaps. And that would be great for the harmonization hub to have a look to see what kind of data people are collecting, so that we can help you perhaps identify, oh, did you know that there's an ontology, and maybe we can help you with that term list. And you are all collecting kind of similar things. Why don't we get together and develop a standard so that that we can standardize the data perhaps for more standardized analysis or better searchability, etc. So that standardization that's coming with more rigor, but first we have to see what you're collecting in the first place, and that is the semantic engine. It helps you easily document your data, write a bit of a description, do exactly what I've done here, write the markdown file and pop it into the library, and then everybody can have a view about the data that you're collecting. So we are not showing us what data you're collecting. You're not putting the data here. You're just putting your descriptions of the data here. And yes, this is a temporary place. This is for active work. And when you are satisfied with the schemas, when we've collaborated to build things that are nice, that you like, we can then put those as their own objects in their own right into repositories such as Dataverse, for example. And then they can be given a DOI. You can cite it in your publication. Your collaborators can cite that in their publications. Other people can find those schemas and they can say, that's really great, except now I need, cow eyeball width or something. I don't know. They're out measuring something new, because that's the challenge with standards, is that the whole point of research is that you're doing something that hasn't been done before, right? But if you're reusing someone else's schema and adding some additional columns, you're going to have that interoperability of the data and the understanding of the data. And if somebody has written great descriptions, that's great, you can reuse them. If somebody has a great list of diseases within the semantic engine, we let you reuse that because we let you import in other people's pick lists. So if somebody has a great schema and you're like, I love your pick list, you can drag their schema into the semantic engine and say, yoink, I'm going to copy that pick list and put it into my schema. So now we can encourage harmonization between the different teams with the different terms. And then you can add your own terms into that pick list, for example. So here I am. I'm going to add this schema to the library. I'm in GitHub, and now I'm going to screw it up because everybody's watching. Oh, wrong one. Told you. Going to upload the file. Choose the file. There it is, right there. So in GitHub, you commit changes instead of save changes. I don't even talk about why it's different. There's lots of great references that go into that depth, and we can do that later. But this is our helping has been functional. How do you accomplish the goal? So now, if you are interested, I can't show it to you right away because what happens is GitHub in the background spins up a virtual machine, interprets the markdown, turns it into HTML, stuffs it into another folder, and then serves that as a web page. So right now, if you click and you're like, oh, my library schema, I just added it, it's not there. It's because this workflow is running. So back here again, I had added it to the schema. This is describing what the harmonization is. Here's the library. We're looking at the back end part. It doesn't look very pretty. It's got the markdown files. It's got the nuts and bolts. And then it's interpreted into a pretty part, which shows up here. And now in Team Loop, we can see the schema that I just added. So we can search for it if we would like. We can scroll down. We can see the entry code lists. There's no farm E because I didn't save that schema. I just pulled an old one in, etc. So this is our desire, that we can have people contribute the schemas that they're using. This is for tabular data. If you have more complex, if they're already published, like packets or whatever, reach out to me and we can figure out a way to put that in so that other people know that you're also working with that data. Don't reinvent the wheel. We can figure it out. The Data Hub is here to support that kind of stuff. Also, if somebody had asked, I would love to see that when you write a schema, if you're having a questionnaire, I would love to see in here your questions. So I'm going to, let's say question 1, I'm just going to do terrible names and descriptions. It's going to be, the answers of question 1 is going to be a text. And then my label is, what is your favorite animal to eat? For example, that's my questionnaire, okay? And you can export this as, you don't have to write anymore. or in your description, you're like, I'm really looking forward to finding, this is, I'm trying to determine people's desires about, et cetera, et cetera, et cetera, right? You can export that. We can import that into the schema library. And then you can see what other questions other people have in other questionnaires. Because maybe you can be like, oh, that's a really good questionnaire. Do you think you could ask these 2 other questions? Because then we could totally use that for our thing as well. So there's an opportunity here. Now, this is not like this fancy thread, like what is it, Quattro or the other expensive ones that have like the threading and everything like that. We're not putting that information in here right now. It's just a list of the type of questions that are being asked, but that means it's searchable, and that means that other ICT groups will hopefully be able to find collaborators and questionnaires and opportunities to work together. Okay. Are there any questions about the semantic engine or the organization of GitHub? Yes, Michelle. Yes, I did not. So one of the checkboxes there is that you can check that data record, that data attribute that you are collecting is sensitive, and we provide guidance on how to decide that or not. And the idea is that downstream, it's a flag. So it's not breaking anything. It's just flagging that data to tell other people who are using your data set that to be cautious, that there are sensitive flags in that data set. So you could write if you were writing scripts, you could say, if the data is not sensitive, import the data for analysis. For example, it's ways that you could immediately flag the data to be left out or to be anonymized, or we have it when you're verifying your data that you can pull it into the verification engine, but it points out that you should be cautious with this data because of sensitivity. So both the semantic engine with the data verification and the data harmonizer that Damien is going, these are locally run. So you can just, the app loads and then it's not uploading the data anywhere. It's not going up to a server and then coming the data when you're checking it with it, which I haven't shown you here, but we have that you can enter and verify data in a web page. You can also generate that text README that you were missing or a data entry Excel. There are other ways that we can reuse. That's the major thing that we wanted to do, is to take workflows and objects that people are generating already and make them machine actionable. Because when they're machine actionable, you're no longer in the paper card catalog. You're on the computer searching and getting the computer to do the hard work of sorting and finding and everything like that. And we can't do anything until it's machine. We can't do anything easily until it's machine actionable. So that's really what we're trying to do here in the Data Hub. Yes. Yep. Yep.
But now, where would I put the method?
So in the method, I would put that in the description. This trait is measured according to DOI such and such, because perhaps your methodology has been given a persistent identifier, which would be really great because then you can reuse it. But you could it could have another name or something like that. But I think it's really great that we should take advantage of the persistent identifier ecosystem out there and put a PID on everything. And then we can reference it and grow it, as it were, build on each other. It's not just, PIDs aren't just for, DOIs aren't just for publications, and they aren't just for data sets. They can be for other digital objects in their own right that are something that you think would be useful as an independent thing, such as a methodology or a schema or an ontology, etc. Any other questions? Okay, first. Yeah, no problem. Yep. Right. So the question is about how to incorporate this, especially in a GELS workflow. So this is for data collection. So if you are collecting survey data or other kinds of tabular data where you can put the results into a table, then you can describe the data that you are collecting using this, and we can put it into our schema library, and other people will be able to search and find out what kind of data that you're collecting. I remind you that this is public information, and if we want to change that, we need to have a conversation and some money because GitHub likes it when it's GitHub is free to use when it's public, and that is a resource that we have leveraged. Now we are talking about putting up a discussion forum for more private information, but I think there's a lot of value in the public development of standards, etc. Also, in your question. The resources from here. So when you're publishing your data set or whatever, what I would really do is I would publish, if I was publishing a data set, I would also publish the machine readable zip file that comes out of this, or the JSONs that come out of this, so that it's next to your data. And I would also put that text file, the README text file, because what the rule of thumb to use for when you put data up is, could you have read it 20 or 30 years ago? Text file, probably yes. So that's probably something that will continue. So you should also put your documentation up in a text file. And the semantic engine lets you generate a text file from that information so that it will be available in a repository. And then also, if I had written a schema that I was proud of, that I had put in a fair amount of detail in that was corresponding to a publication, I would also really consider putting that in Dataverse as an object in its own right, alone. That means it's a Dataverse repository with just a schema. And then in my publication, I would say the data has been organized according to schema name such and such, DOI, and point to that repository. And the reason is then other people can go to that repository and they can collect data the same way. And they can say, we collected data according to DOI such and such, and point to the schema. So then you're helping the reuse of these kinds of digital objects that people are generating. Other questions? Good? Yes.
How granular or
I would say that when you're documenting your data, you will have a schema for every data set that you're collecting. And you will identify that you're doing a lot of duplication, and that you're like, if I just stuck these three together, I'd have a lot less to do. So the semantic engine is promoting a bottom-up approach. Damien is familiar with a top-down approach where you're taking the bird's eye view and you're like, oh, look at the landscape. We can pull this together and make this as a recommendation for other people to use as well. Okay. Especially in agri-food, we've seen that there's been lots of efforts in order to standardize schemas from a top-down approach, but they weren't, like, research is often novel. You're measuring something that hasn't been measured before. So that's why we developed the semantic engine to feed, to reach a niche that had been underserved, which was where there isn't a schema that does what you want it to do, and now you can start from the bottom up. And then if you find someone else's schema, but it doesn't have cow eye width, which is your special project, you can edit that schema and add those attributes in. So then you don't have to go out and rewrite their descriptions and stuff. We're trying to promote reuse for your data sets. And hopefully when you have found that there's these three schemas that are actually probably one schema, that we can also find opportunities with other groups that are close to what you're collecting and develop a standard that we can all use together and document better. And then we have the expertise of somebody like Damien who can go out and match those two ontological terms so that suddenly it becomes from a data label embedded into a knowledge system so that you can do logic. And this is really important as we move more. So now you can call your data AI ready, right? Machine learning ready, because in order to make logical deductions on your data, you need to connect your data to some kind of ontological knowledge system. That is how you can reason to be like, oh, I'm I'm asking questions about ruminants, and this guy has a cow, and now you know that the cow and the ruminant, that you can do that kind of those kinds of, and you can't do that until you've been connecting your schemas to ontological resources that already exist. And that's when we move into the work of the data harmonization. And that's where something like the data harmonizer is working at a level of greater standardization. Yes. Yep. This is a great question. We have been asked this before. So the question is, how can we reuse schemas, and like, can we put them into an app, etc. So we have not developed apps that read the schemas, but they could be developed. Our version of an app is that we have data entry Excel sheets, and then also that we can enter and verify data just in a web page. So I'm going to pull up enter verify data in the web page. Through, I am going to upload a data set. Data with errors. This is where I'm matching. So the schema called it, well, here's one that didn't match. The schema called it farm, but my data called it site. So now farm equals site. So then when I go through my data set, I can go to the very end and I can add another row, and I can add a new measurement that I have done, for example. So I can do that within this web app. Local, you're not sending your data somewhere. If you close the window, you've lost your data. That's because we're not saving it. No data saved without exporting. Promise. And then you can export your data, and then we let you export your data as an Excel sheet with the special instructions, or you can export it as a CSV, and you can change the headers to match, you had done with the brackets and everything, but now you can harmonize it to what the data column headers in the schema are, etc. So we do not have any apps, but now that your schema is machine readable, it could be done, right? Oh yeah. Yep. So what we have, what Alicia was talking about, is what we were developing here at the University of Guelph. After this, when I say export the data, I'm downloading the data, but we are connecting it to a backend because we have barns with servers, and our researchers would like to contribute data up to those servers, so then they can import their data via here. We can run a verification check, and then we can hit export, and it'll go up into our barn servers in a quarantine zone where we can check it and then make it available to other researchers. So we're using this as a generic data importing technique, because whatever schema I give it is the data that it can accept. So I can set the rules about which kind of data sets we're accepting. There's no user control here. So the user control comes from the barn system, but here anyone can, this is open on the web, anyone can come and upload a data set and download the data set. All you can do is download the data set. Good. Any other questions? Yes.
I like the idea of making harmonizing the data within projects, but to be honest, sometimes projects have all of them. And
yeah.
Other than the larger macro scale of agriculture, there's a lot of that is really going to be harmonized. But if I wanted to make generalizations, let's say about the role of soil microbiome for green gases in a gray system, I'm going to go south. Right? I'm going to go to Montana and Wyoming and Colorado, because that's the system, and there's tons of data.
Yep.
And so I'm curious, in the harmonization world, how do we harmonize within this group, but not make ourselves distinct from these other collaborations that are going to answer related questions?
So Damien's going to talk more about that, but my first impression would be, here now you can learn the GitHub skills on how to run a harmonization effort, and then you can invite, form a collaboration with colleagues and say, hey, we have experience in developing standards. Let's all get together. We'll meet once a month. I've been on other systems where they do this kind of standardization. We'll review the pull requests. We'll see what we like, and then we'll pull that in and decide on a data standard. Then we'll call that version 1, publish it, release it with a DOI. That would be how I would proceed, because we and if you would like to run that kind of standardization with the support of the data hub with external partners, there's no reason that we also couldn't support that development, because we should not be limited to the work that we're doing here just with these 9 ICTs. Did I cover it, Damien? Well, you'll talk more. Damien is going to go on next about more work with harmonization and the kinds of opportunities. So any other questions? Okay. Damien?
Yeah, so there'll be a slight difference in the French version in English, I have to admit. I just animated things a little bit more to talk through. Yeah, so section is leading off with data harmonizer, but I'm going to get into data standards development. We put data harmonizer in here to sort of compare with the Guelph effort and look at a few different priorities, but really so many softwares are coming towards the same goal. That is, make explicit data standards and then run tools off of them, validation. So data harmonizer is that. We made this separation of specification and then the spreadsheet-like tool to use it. And some points here: standalone browser-based editor app that handles tabular data, pick lists, validation, customized exports, and provides guidance. So you've done a wonderful job of showing how all of that is necessary and needed to compose inside a specification. So our tool was actually developed in the fray of COVID epidemic outbreak, and it was meant to meet a few different goals. One of them was that the app had to be standalone on the browser, no IT permissions needed to run it on your computer. The second need was that it gets to load up your data, edit it, and save it. And you might be using TSV, CSV, XLS, XLSX, something out there that your agency likes. And then one of the third objectives was needs to export off to VirusSeq portal or NCBI bioportal if you're sending samples off that way. So there's a conversion from your native format to another. And all of that has to be bundled into the app and running off of a specification that's actually changing every 2 bloody weeks. They're adding pick lists on. So that means we don't want to burden people with having to change their spreadsheet somehow. We need to actually have that spreadsheet loaded separately. The specification loaded separately. The pick lists to immediately work with the new selections. So here we go. That has led to data harmonizer and mentioned the Cancogen VirusSeq portal, 100 different fields of information related to the sorry, I'm just blanking. related to the epidemiology of the person, the case information, the location of the sample, geographic location, the bioinformatics, sequencing parameters, so on. So there we are with the file menu that allows you to load both your data and to export to other formats. You have a bunch of settings for viewing all fields or required fields, moving to desired field. You've got 100 fields. Who's needing to enter what? Maybe we just want the yellow mandatory fields and forget about all of the other options. Validation to make sure it's in good shape before it goes out the door, and if not, to correct errors. And then extra information, help information. So all of this is find the fields you need, learn what to put in them, fill in the ones that apply to your need. Maybe not all the fields do, and then verification. So the idea of running data harmonizer on templates, basically one template for kind of table of information, meant that you have a template menu where you get to select which specification you need to use. And so some of these specifications are just like one spreadsheet table, but others are actually variations like MPOX and MPOX International. They have 95% the same fields, 5% different fields. So really enabling users to pick off of that. We've got a couple of other specs. I'll be talking about the GRDI one in more detail as that case study of developing a specification. But wastewater, other viruses, bacterial AMR stuff. And then there's an example of all the kinds of settings that you can have, such as jumping to sections of fields. All of this to make what's traditionally a spreadsheet app that would have been rather frustrating to use with 100 different columns into chunks, sectionable chunks that you can zip around. Anyway, so that's the tool. It's gone through a couple of years of development now since COVID, attracting a lot more use within federal agencies and other organizations, including the National Microbiome Data Collaborative, which is collecting soil samples from around the world. There's time I might show a little dip into that site to show how they're visualizing all the data. So it's being used as an app within that environment. Pick lists, multiple selection lists. All of this is actually doable without actually needing ontologies. Everything I've said so far, you don't even need an ontology in sight to do all of this or controlled vocabulary. This could all be just your own customized data set. So this jump between creating a specification with your own fields that nobody else has researched or studied, and the ontology is actually an extra layer on all of this, an optional layer. But these particular pick lists are actually all backed up by an ontology ID. In this case, this standard didn't need to publicize that, so you're not seeing it in the user interface. Multilingual, very helpful in our country, but also in the rest of the world. Many countries would rather have dialogue about data in their native language, and that means both the interface to the language, but it can also mean saved file. Like you've got all these pick lists in different languages. Maybe you want to share these pick list options in those languages out, be able to load them back in, and then actually hit a button to change your language setting and suddenly see the data be written according to the appropriate language. So we have targeted that, and it's in beta mode, actually, just about to be released. So then that's showing that there's a user interface level, multilingual functionality, and then the content. And all of this is captured inside this one specification file in JSON with, in this case, it's showing the French and English overlay. So we're really focused on open source, publicly accessible specifications, and that's reflected in this DCC project and many academic and open source government data initiatives. So based on GitHub, using a data schema tooling set that's out there that other people are supporting too. And then the data harmonizer tool sitting on top of that. And then we come to the OWL ontology and third-party schema, vocabulary, interfacing. So semantic layer for comparability, because so far I may have done a beautiful job managing my data, and yet it's completely zero comparable with anybody else's. So that's where we get into taking that look at the data attributes on the fields and the pick list items. So a number of you will probably be familiar with this minimum information sequence mixes standard by the GSC standard consortium. So they've got these packages of recommended metadata points to collect, and they've labeled them. So there, I could spot 4 of them directly applicable to agriculture and genomics work. They've got an agriculture package, food, farm, environment, plant associated, and soil. So here's the list they're showing, and just zooming in on the soil one, sample name, project name, depth, and vegetation classification from 1 or more standard classification systems. So they're being a little open-ended about exactly what's popped into the field at this point. But it does have this URI, this mixes term, which would give you a little bit more semantic comparability. Not in the gold standard there yet, as the databases are still free to use their selection of controlled language. And so this one may not have that one's controlled language. So you're still hiring master's students to do mapping between schemes. So part of this whole ontology enterprise is actually to come up with a recommended set of ontologies out of the vast array of ontologies that are out there, including agencies that are doing these siloed attempt to curate their own hierarchies of terms. So another great source of at least coding names and labels, and then maybe down to the semantic level, is the NCBI biosample bioproject SRA set of standards, and they have a site you can go to where they're showing their specification. And so to zoom in on the plant version, they've even got an Excel spreadsheet that lays out all the columns across the way and has a similar kind of click on it and more information about that field. So now we get into lat long, could be a standardized name that you guys are viewing in your systems. If you also wanted to validate that the string information is just right. Now that is very much more pinpoint. This database and that database having that spec, we can compare immediately content. Age is a little more tricky. So harmonization name is age. Age at the time of sampling, relevant scale depends on species and study, seconds for amoeba, centuries for trees. So age itself doesn't quite cut it as a semantically comparable unit within your data set. So please don't just call it age. Or if you do, then please back it up with a more semantically pinpoint term. So where do we get those pinpoint terms? Well, we want them in ontologies. So here's the OB ontology, biomedical investigations. And of course, they're people-oriented, but they've actually got some plant age kinds. So age since germination, hatching, planting, sowing, okay? So that's more accurate. Now, maybe you don't, in your user interface, want to use that long name, but at least reference the ID for it. Then we're working towards getting out of this Tower of Babel. So, generating data standards. So say you want to get involved in this whole enterprise in a small way or in a big way. So there are different levels of getting into this business. And so what we're hoping in the DCC side is to help you into whichever level you best want to be in, from more of a minimal to the all-out ISO standard or CSA, Canadian Standards Association level of contribution. So the very beginning contribution level is structured vocabulary, supporting structured vocabulary such as ontologies. So that means having at least one staffer, say, liaising with us or taking it upon themselves to get new term requests into appropriate ontologies so that you have those URIs for adding to your schemas. And the other level that you can be offering is the expertise about how that term should be defined and in collaboration with colleagues from other universities. So there are a lot of folks who interoperate with different universities, collaborative ontology curation teams within the open source world, and some meet every week, some every 2 weeks, some every 3 weeks, and some are just sort of coaxing along their ontology slowly as the year goes by. That's the first level, and it's very appreciated. Food on curation meetings that we have every 2 weeks, we've got anywhere from 5 to 10 people showing up from different ages on a curation topic. And sometimes it's slow work. Sometimes you're getting through 1 or 2 terms per hour. Sometimes, you know, a big day is when you actually make it through 10 terms, like, because they're all test tube and catheter and, you know, easy ones, right? Should be easy. Okay, partnering in the development of shared data schemas. So that's what I'm talking about, the second level of interoperability, which we were talking about, working with other universities from other states, working with NMDC. You know, maybe they have a soil sample schema that needs to be fleshed out a bit more. And the key there is that, yeah, the data type is underserved by existing standards. Protocols.io is also an example of this collaboration, where it can be just you working on a protocol submission, or you might be working with others. Elevating formally shared agency-sponsored data schemas to global standards. So at some point, we've got these informal de facto standards happening. And in fact, you can look at every ontology as a de facto standard if enough people are using it in the open source world. But moving it up a level is CSA or ISO or RAID, and that could be a 5-year process. I'll just note that it's not all about the data schema content that is explaining your data sets, but what about the experimental design that led to them? So in fact, having beautifully described data sets isn't enough for fair data comparability. We actually need that experimental model as well that led to the data points. So we'd be happy to engage with folks about that in animal studies. Of a great tool online that visualizes your animal study down to splitting a treatment given to a herd into 2 days because you can't apply the treatment enough in 1 day, and having that level of detail captured. So, okay, so generating data standards. Data needs assessment is the first thing, which is that collaborative community process and reviewing existing standards, taking a look at the gap analysis and finding out which vocabularies are there, reviewing them, seeing what maps to existing terms, new terms, then finding out where the semantic mappings are earlier or later in that, implementing with the tools as we've kind of shown this morning, testing, because it's not all happening at once, the iterations of that, and then the GitHub dissemination and printing it out and maintenance. So I'm going to use a case study of the GRDI AMR, antimicrobial resistance project, which is initially involved 6 federal government departments testing the whole food chain for possible factors involved in antimicrobial resistance developing in bacteria, lateral gene transfer, and So the goal was to understand foodborne related AMR, and it ended up being quite a universe of sampling situations where they're needing to gather what ended up being at least 150 fields plus all of the AMR results against like 60 microbial drugs. So that's one heck of a wide spreadsheet at the moment. A bit more about that later, but needing to capture the sampling strategies and methods as well as the resistance profile. So there's a paper on this. I've left a link on the slide to it, but suffice to say, needing to describe kinds of food, kinds of location where that food existed, and also straight to soil samples. Wastewater, I think, is also covered in part of this, and factory equipment. So needing the vocabulary for all of these possible contexts. So obviously lots of different categories there, and what they decided after trying to map it directly to NCBI biosample fields, they realized that wasn't a good fit. NCBI biosample didn't have enough fields, so they started working on their own, but they still did use a framework. We helped do the ISO standard for. Took about 5 years to get published, but it was all about foodborne testing of microbial activity along the food chain, from the farm to fork, and getting all the bioinformatics parameters in. So that led to a sectioning of fields into different areas. So talking about the food sample itself, if the sample is coming from food, getting particular fields involved and their pick lists for kind of food product or the property that it might have, whether it's frozen or raw. Animal clinical samples. So this isn't food, it's coming straight from livestock. May not be in Canada, might be somewhere else. So now we're involving concepts of host organism and sample and the relationship between the two. And then environmental sample straight off to conveyor belts and other machinery. So there's no biological target directly. You're suspecting there might be something. So so the reason I bring this example to you folks is to show you that your data may play a part in other investigations where we're trying to figure out other kinds of problems. And this is an example of very wide spectrum of sampling activity. So the sectioning of these field types, won't get into detail, but the semantics of the chains of custody, where they are, who created them, the identifiers, sample descriptions, that host or other sample type, experimental design, the kind of strategies and controls, and on and on. So complex, each of those areas has to be examined, and it helps if there are existing standards to branch off of. And what this yields is, in the case of that ISO standard, there were sections of fields dedicated to each of these missions, and they can all be mixed and matched when creating new standards. I think the diagram shows two of our existing specs and what they share and what they don't share. And so this comes to the schema library. Unfortunately, we're just on the cusp of offering plug and play, pick your standard field off of recommended standard field and pick list items off of recommended sources of vocabulary. So that's coming, at least it's here visually with this idea of being able to search on the data hub for fields of interest textually. I thought I would look around for an image of how important these standards are. What do we trust our lives in? what's a construct of hundreds of possibly thousands of standards that our lives depend on? So, but then of course I thought, oh, agriculture. Well, we actually also depend on tractors and all the standards there for our lives as well. Many machines, but now in fact we're into the data world. It's the standards that are involved in the data abstraction. So, my interest is in creating sort of a knowledge graph of all the pieces that we're expecting to need to gather here to help keep track of where the data repositories are, what versioning is required of the data, or licensing is required. And so Will has also undertaken data type, the study of the data types. And there we are. Ah, yes, right.
So for the last section, it's very brief. It's about data governance. Now, we've seen with the data documentation, data schemas, that this is something that's been well worked on. There's lots of data schemas, there are lots of tools available. For data governance, I'm willing to bet that the majority of things are one-on-one data agreements that are written by a lawyer or something and then individually signed. And there's going to be more benefits that will accrue when we can make these kinds of data governance information machine actionable. So what we are trying to do within the Data Hub as well is at least make the steps forward of digitizing data governance. Not that it's, and again, this is the concept again of portability, that it's not the data governance rules for your system that you're using, and then the next system we have to reinterpret it all over again. There is opportunities to kind of look at things that are already existing. The example that I like to use is there's certainly been a lot of work in automated governance of digital objects within like the music space. So if you make a TikTok video and you use Rihanna in the background, there is a data license agreement that has been automated and brokered on your behalf without you being aware of it through some kind of digital rights licensing language. So because they're able to automate that, they're able to do a lot more with sharing and reuse within the music industry. So there are these precedents and examples that we can work from. So in the new year, what we'd like to do is to understand existing agreements and the requirements, and try to break down the idea of what are the components that people are interested in that go into data sharing agreements and data licensing models, and to try and express that in a machine actionable model. We can draw on existing like open digital rights language. There's the data uses ontology for terminologies, etc. And we will want to proceed with that work in the GovHub, which is another GitHub repository, and also in more private discussions when we have a more private discussion forum set up. That's the last slide. So are there any questions before we close out today's session? Yes. Yep.
Are research and data the privileged information themselves between the parties who sign it, or are those themselves shareable?
It depends. It depends on how people, the users, want to be able to make that available. But I would not require. I would require that the language that the agreements are written in becomes a public standard that we are adopting, and that the agreements between might be something that you would keep probably private. But there is going to be examples. So what is certainly efforts trying to do is that, like as a clinical patient, to be able to mark up my data, perhaps publicly, to say this data set can be used without constantly requiring to come back and ask me, I'm setting these kinds of usage restrictions. And that can, so you would be able to tag data sets to help try and automate decisions around licensing agreements. So that's the goal, because we're not going to get any, if it's always the lawyer speak and the written documentation, we can't advance with that kind of system. So we're going to be exploring how to move that forward. And I wouldn't say that the agreements have to be public, but there might be features that one can mark up a data set with, kind of like the reuse, Creative Commons, those licenses, but they have a few components to a Creative Commons license. So there's a little bit of mixing and matching, but it's a very simple model. And they tried and failed in more complicated digital licensing because that simple model is simply not sufficient. But as the music industry has demonstrated, for example, that there can be terms and conditions and geographical restrictions and thematic limitations, et cetera, that we could potentially at least describe in a digitally actionable way. Will?
Not an attempt to replace lawyers. Still an attempt that there will be detailed agreements. You should be still able to define how the data can be used, if it's open or not. General terms can be tagged to the data, and contact information as well about how to request data, and to add contextual information before you can partake in a process for requesting data.
Makes sense.
Mm.
That was mine. Where oh, I don't even know what I'm allowed to listen to other. So I wouldn't have the knowledge of
Yep.
what I could have.
Because if we can see the agreements, then we can pull them apart for their components and try and take the textual documentation and express it in a machine actionable way, or most of it, or try. Yes, Brian?
Most of you definitely. Most of it is. So, bunch of negotiations. We're trying to take the time. Non-public. That sort of. But it is a.
Was there another question here?
Very
Mhm.
sort of. Helpful. Yeah.
Mhm. Yes, I do not see this as being a check at the end of this project. So, yeah. Yeah, because we're facing the onslaught of AI training data. And then my question is, did your AI training set use data that you had the rights to use and to be able to track all of that? There's no getting around that this is going to have to be digitized. So the first steps are going to be to look at the components, to look at the needs, to look at, so we might have to, lose a bit here to gain a bit here, and have a bit of awkwardness here, because then it can be expressed in trade-offs back and forth to develop a language of people and computers to express digital rights. Yeah. Mhm. Right. Excellent. Hello. And stewarding of the data. We have multiple roles: the owner of the data, the steward of the data, the curator of the data, and defining these kinds of roles and what they are, because this fits into the OCAP principles that the community, the Indigenous community, is the owner of the data, and their academic partners might be their current stewards of the data, and that stewardship could change throughout. But there's ownership and stewardship and the rights associated with those roles. Yeah. So I'd like to close today's conversation then with the next steps. What are the next steps that we are requesting from you here today, and also the next steps from the participants in your project? So bookmark the project website. There's the URL right there. New things will appear on the website. That is the start of where we go from there. Participate in discussions that we will be starting up right now on GitHub, but it's going to be moving into a discuss site most probably. Your GitHub usernames and ICT group affiliations so that we can start adding you to the project and start building up together. Document the data that you are generating using, for example, if you have tabular data or questionnaires with the questions, put it into the semantic engine so that we can publish those schemas in the schema library. The schema library takes Markdown. If you have data in other contexts that you already have documented, reach out to me. Let's get that in Markdown and up on GitHub. You can find out what others are collecting by browsing the schema library. Participate in the data standards development. So first targets that we can set out and work together to try and harmonize data internally and externally. There's an opportunity there. And prepare for data governance discussions then in the new year. We will really need to hear from you about what your data governance needs are, or I'm going to invent them like I did all the other examples in the data schema. So let's please participate in that so that we can build it so that it's useful. For the people that are, for example, students or postdocs that are part of your group, have them also bookmark the website. Maybe they can go through and work on their knowledge development by reading through some of those sites, learn how to use GitHub, share their GitHub names as well and ICT memberships so that I can add them, and documenting the data that they are collecting and adding it to the data catalog. That's the schema library using the semantic engine, and then sending it up into GitHub with the schema library. So those are some very concrete first steps that we are requesting from our members here that we can start to kickstart this process. So thank you very much for your attention. It was a long morning, and we really appreciate how well everybody participated, and extra bonus points for the people who already gave me their user account names.